All right, let's back to question 6. Now, as I mentioned, this trap point is come from a public exam questions, and at that moment, many students got the incorrect answer. Is because they focus on the final result only. Teacher say when there is extra NO2, then equilibrium position will shift to left. All right, pale yellow, very good, lighten color. But this is correct, but not the whole story, because they forget to mention that time is needed for the equilibrium to achieve. So they forgot to mention this one. At first sight, the reaction mixture become darkened is because the concentration of NO2 increase. This is before new equilibrium is achieved. Alright? Then, according to the Leshonian principle, the system will respond by decrease the NO2 and net backward reaction, and this position will shift to left. That's why this will drop and N2O4 increase or rise, and the reaction mixture become lightened. So, as I mentioned, many students forget this one, okay? Don't forget the first two. Don't forget to mention the thing happen before equilibrium is achieved. So, many students mention the later one, get marks, but forget the former one and lost marks. And that's it. Alright, okay, the pressure, okay, the second one will be the pressure change. Now, the equilibrium position will shift to reduce the change, right? So, I always use the following story. If your house become bigger, then of course you will buy extra furniture, right? But if your home becomes smaller, then it is time for you to throw away those unwanted things. Why? Because you want to against the change, right? So this is related to Unit 38, Avogadro's law. Or I should say this is for gas only, because this is no point for you to study liquid, aqueous, or solid component. Okay? So, Avogadro's law. More number of mole of gaseous molecule, more pressure, or more volume, right? Yes. Here shows. On the left hand side, there are 1 plus 3 equals to 4 mole of gas. On the right hand side, there are 2 moles of gas. Here shows. So when pressure increase, the system will shift to the way with fewer number of mole. That means when pressure increase, the system will shift to right hand side. Okay, let's write it down. There are 4 moles on the left hand side, 2 moles on the right hand side. So when pressure increase, the system will shift to right to lower the pressure. Now here is important. Don't forget to mention this statement. Why shift to right? Because to lower the pressure. Well, in reverse, if the pressure decrease, then the system will have greater number of mole of gas, right? Because pressure decrease, that means the volume increase. As I mentioned before, if your home become bigger, then you will buy more furniture to fill in the space, right? Okay, alright. So what if the number of mole of gas on left hand side and right hand side are the same? So what will be the result in change pressure? Well, the answer is no effect. Okay? Alright, so let's finish the chat point. Okay, first of all, 3 mole versus 2 mole, right? Gaseous particle. When you increase the pressure, so increase the pressure, okay, the room becomes smaller. Increase the pressure means volume decrease, right? Your home becomes smaller, then less furniture will be better, right? So the system will respond by reduce. Okay, the pressure, that is reduce the number of mole of gas. Net forward and to the right. What about decrease the pressure? Decrease the pressure means volume increase, right? So if you decrease the pressure, the system don't want any change. He will do something to increase the pressure and increase the number of mole of gas. So net backward and to the left. Simple, right? Just do everything you can do to against the change. Alright, chat point again. So please pause the video, okay, and we will finish the job. Volume increase, that is pressure drop. Pressure drop, the position shift to left, good, because more mole of gas, right? Then of course not forward, and here is critical. We only change the volume, not temperature. Please write it down. Depends on temperature only. So this is not correct. So the answer is A. The second one is amount of reactant increase, that is net backward reaction, right? Increase volume, that is decrease in pressure. Okay, decrease in pressure. The first one is no, because it's a 3 versus 4. It's 2 versus 1 and 2 versus 1. Okay, number of mole. So decrease in pressure. So 2 and 3 will be shift to the left, right? Because decrease in pressure, I will require more number of mole. So net backward, increase reactant. Alright, again, draw rapidly from P to Q. Rapidly is a keyword. That means it needs time to achieve new equilibrium. Okay, so predict the observations. Now, step 1 is the brown color will be more intense because concentration of both N2O4 and NO2 increase. in smaller. Oops. Oh. Sorry, I have done something wrong. Will be less intense. Be less. Sorry. From P to Q actually is volume increase. Okay, so brown color will be less intense because N2 decrease as in larger volume. Okay. Well, next one is with more volume, the equilibrium position will shift to away with more molecule. This is 1 versus 2, so that will be to this way. Step 2. Then brown color will be intense afterward because volume increase, the system responds by increasing the number of mole of gas. Equilibrium position shift to right. Yes, this is what we want, right? First, it will less intense, then become more intense afterward. Okay? Well, finally is the temperature change. Temperature change is extremely difficult because not only change the equilibrium position but also change the value of Kc. So both equilibrium position and Kc change. Okay? Now, so I will use the story, okay, to help you to memorize. In summer, temperature is high, so we will switch on the aircon to against the change, right? In winter, temperature is low, we will switch on the heater. All right, keep in mind for this story, okay, keep in mind. So here shows when temperature increase, so the system will try to reduce the temperature, just like summertime, right? When temperature decrease, the system will increase the temperature, just like in winter. Okay, now, so how can we use this story into our exam-based questions? Okay, use Haber process as example. Now you can see this one. Still remember what it means? It means forward reaction is exothermic, right? Forward reaction is exothermic. Okay, if forward reaction is exothermic, I will think this is a heater. Now, good. Keep in mind. Exothermic is heater, right? So, let me write it down. Forward reaction is exothermic, which increase temperature, right? The backward is endothermic, which decrease. Good, right? Easy to understand. But okay, here comes when temperature increase. When temperature increase, just like summer, right? the temperature is high. So what you will do? Will you use heater? No, right? So no or less forward reaction. In summer, I prefer to use aircon. So this will shift to left. Because if forward reaction is exothermic, that means backward reaction is endothermic, right? I will say the backward reaction is the aircon. So easy to understand, right? If in summertime, I will prefer use aircon. So I will prefer backward reaction and shift. That means the equilibrium position shift to left. That's it. You can handle or you can complete every question in DSE with the heater and aircon story. Trust me. Okay? Now, let's do it. The chat point. Now, good. This one is forward. Okay, let me write down. Forward is heater. Or you can say backward is aircon. Right? Alright, so which one will increase the amount of HI? That means I want forward, I should use another color. That means I want more forward reaction, right? So what should I do? Forward reaction is heater. So when you will prefer to use heater? In winter, right? In winter, that is decrease in temperature, right? Alright, this is one point, but what about the others? Increase the pressure, because 2 to 2, the mole ratio is 2 to 2, so you have no preference in change the pressure, right? What about adding H2? Adding H2, the ball will roll to the product side. Good, very good. So the answer is C. So you can handle, right? So what about this one? Now, I need maximum yield of styrene. That means I want this to be higher. That is, I want more forward reaction. Okay, forward reaction is it's positive. That is aircon, right? So when you will, I want more aircon. So when you will need aircon is summer, right? Good. So increase temperature, right? Well, next one, what about pressure? Pressure is 1 versus 2, so less will be better, right? The lower pressure will prefer more molecule. So the answer is C. Because lower pressure means more volume. Alright, so 3 and 4, so it's your turn. Okay, it's your turn. I will check the answer for you. Alright, so here shows the forward reaction is heater, right? This is exothermic reaction. So increased temperature, summertime. Summertime, of course, I don't want heater, so I want aircon. So backward reaction is better. So the equilibrium position is shift to left, right? The second one is, what about increase the pressure? So you can see 3 to 2. So increased pressure prefer less molecule. That is the equilibrium position shift to right. Finally, what about suitable catalyst? Well, catalyst only shorten the time to achieve equilibrium. It will have no effect on the position. Okay, no effect to position. So no change. And finally, which of them will change the equilibrium constant? Still remember? Depends on temperature only. So this A1. Well, this one is the same. First of all, forward reaction is endothermic. This is an aircon. So first, increase pressure. Okay, 2 to 2. So no change in the amount of NO in changing pressure. The next one is increased temperature. Increased temperature means summertime, right? Of course, summertime I want more aircon. So net forward reaction and increase the amount of NO percentage. Easy, right? Again. Well, finally, so what about the calculation of new equilibrium concentration? Okay, is actually the same job as what we have done before. So, okay, I will do it with you again. So first of all, please do it by yourself. KC. No problem, right? So now it's turn to achieve to write down the RICE. Alright, so originally, okay, this one is 0.045. Oh, double check, molarity, good. This one is 0.03, but the H2 suddenly increased to 0.2. Okay, so in order to find the values, okay, so originally this is 0.15. So now you can see we got more. So we can expect this one is more, so should be shifted to left, right? But before do everything, we need to find the value of Kc first. So let's bet our job in part A. This is this one. Okay. Yes, we don't know how much mark will be contribute in part A, so we can do it back. Okay, the marker will not care. Okay, they will only care about the answer. Okay, so net backward reaction. So I can say the change is minus x, and positive x here. Okay, make sure you understand. So some of you may wonder, what if you do it wrongly? Oh, don't worry, you will get a negative value of x. It's still fine. Okay, so 0.045 positive x. Okay, let's do our job. right? It's complicated. Oops. Okay, it's complicated. So you can see actually the calculation is just time consuming. It's not difficult at all, right? Alright, so here I got two positive value again, but this one will be rejected because you have no point to lose 0.214, otherwise the hydrogen concentration will be negative, right? Okay, so the concentration of gas, let me write down. Oops. Okay, like this. So you can see the key point is once you get the correct position in the RICE, everything is simple. So you please pay attention to the position, okay? Right, let's finish the final questions. Okay, here. Alright, first of all, extent of decomposition means that 5.25% of COCl2 is decomposed. Okay, so you can write it down. Okay, so value of Kc. Oh, okay, so first, finish your job first. Okay. Well, after calculation, 5.25% of 1.6 is 0.084. Right, then for part C, we need to copy the RICE again. Time equal to 0, but this time we have half the concentration. Okay, for everyone. Change and time in equilibrium. So we can expect with more space, because pressure decrease, right? We should move to the product side, which has got more molecules. So this should be increase, increase, and decrease. This is expected. So if you finish the blue work, then you can almost done your job. Well, next is a just complicate job. Time consuming and nothing special. Okay, so let's start. Alright. Here is the quadratic equation time again. So we reject the negative value. So finally, CO concentration equals to Cl2 equals to 0.042 plus 0.0167 equals to while the COCl2 is like this. Okay, so you can see there's nothing special, just time consuming job, and be careful, it's enough. So don't forget to finish all your exercise set in past paper. This is extremely important for you to have practice. And until next time, okay, so if you have any questions, please feel free to ask me. Okay, I will spend time okay, to explain to you. Okay, it's my pleasure to do it.